This video summarizes power and energy consumption of a CMOS inverter. Let's calculate the average power dissipated in one period. Assume the input of inverter is an ideal square wave with a period of t, as shown with dashed lines. Static power can be neglected in CMOS inverters, so the average power is equal to the average dynamic power. During the high to low transition, NMOS will be active with discharging the capacitance. So there will be current flow through the NMOS. During low to high transition, PMOS will be active. So there will be current passing through PMOS. Dynamic power dissipated in one period is the power dissipated on NMOS and PMOS. When NMOS is active, Vout changes from VDD to 0. The power dissipated at this transition is C load times VDD squared by 2. When PMOS is active, Vout changes from 0 to VDD, and deriving the power for ID expressions of PMOS, we calculate the power dissipated on PMOS again as C load times VDD squared divided by 2. Therefore, average power of CMOS inverter is C load times VDD squared times F, with F is the switching frequency, the inverse of the period T. Power delay product is used as a performance metric to evaluate power dissipation and speed of the inverter together. It is the product of average power and delay T. Therefore, power delay product is C load times VDD square. It can as well be defined by the second expression, with P star is average switching power dissipation at the maximum operating frequency. Tau P is the average propagation delay that we have calculated in the previous videos. Factor 2 is here to indicate the two transitions of the output, high to low and low to high. So, using this new equation, can you derive our first equation of C load times VDD square? And here is a second exercise. I want you to show that PDP, power delay product, is not a fair metric if fast operations are preferred. To do that, use this simple example. Assume we have two adders, adder A and adder B. They have different speed and power consumptions as given in this table, but their all other specifications are identical. So, which adder would you prefer for your design? Or in other words, which one do you think is a better option? To find it, you should first compare their speed and power consumption, then calculate the PDP and think if this PDP is enough to compare them.